Alright, this lesson is just a quick review about how we prove that triangles are congruent using these postulates: side, 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 angle, 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 side, or hypotenuse, leg. It's worth focusing on the fact that there are two combinations that definitely do not work in terms of proving triangles are congruent. If we have an angle, angle, angle situation, that will not prove that two triangles are congruent. Or if we have side, side, angle, which I tell students if you wrote this backwards, it would make a bad word. So that should help you remember that that one is not legal. It doesn't work. All right, but angle, angle, angle doesn't work either. This is just a quick review of it. There is a full lesson available if you look for triangle congruence on my YouTube site. You will find a full explanation, but this is just a quick review. All right, so looking at problem number 1 as an example, the first thing you should always do is look for if there's something that you can mark that's not already marked. We have all these sides that are marked congruent, but this shared side is the same for both triangles, so we should mark that. So looking at these two triangles, we now have a side, and a side congruent to a side, and a side. So that is going to be side, side, side. So we will say yes, these triangles are congruent because of the side, side, side postulate. Similarly, looking at problem number 2, what can I mark that is not already marked? These angles right here, kabam! When lines intersect like this, they form angles, pairs of angles that are called vertical angles. And vertical angles are always equal, like these two are equal. So now look, what we have here is two angles and a side congruent to two angles and a side. Let's see. Look at these possibilities. Here I have two angles and a side, but it's called angle, side, angle. And here I have two angles and a side, but they call it angle, angle, side. Now what's the difference? The difference is the order matters. If I have two angles and the side in the middle, that's angle, side, angle. If I have two angles and the side that's not in the middle, then that would be angle, angle, side. So looking at this picture, I have these two angles. Okay, see how these angles are right next to each other? This smiley face represents the side that would be in the middle, like right between these angles. But that's not the side that we're given. So the side that we're given is not between the two angles. So I have two angles and then what they call the non-included side, the side that's not in the middle. That's why this is angle, angle, side, not angle, side, angle. Okay, so it is one of the ways we can prove triangles are congruent. So we will say yes, but the reason we will state is angle, angle, side. Two angles and the non-included side means angle, angle, side. Looking at number 3. What can we mark that is not already marked? Again, we have these vertical angles. 1, 2, 3, 1, 2, 3. These angles are equal. If anything, this would have been an angle, angle, angle situation, which I was mentioning right at the beginning. But having three angles that are equal, that's not enough to prove that two triangles are congruent. That's enough to prove that the triangles are similar, but not congruent. So that's going to be a no. All right, look at number 4. We should go ahead and mark that as congruent for both triangles. And so what do we have? A side, and a side, congruent to a side, and a side. So once again, we can say yes, And once again, that is because of the side postulate. Okay, what else? Look at number 5. Again, we have the shared side, so let's go ahead and mark that. Now, for each triangle, so looking at triangle ABC, for example, I have a side, an angle, and a side. Okay, and looking at the other triangle, I have a side, an angle, and a side. So I have 2 sides and an angle. The question is, 2 sides and an angle. Is this side, angle, side, which would be 2 sides and an angle, side, angle, side? Or is this the bad side, side, angle, which doesn't work, because that also involves 2 angles and a side? How do I know the difference? Again, if the angle is between the 2 sides, then it'll be side, angle, side. If it is the non-included angle, the angle that's not between the 2 sides, then that's a no. That's would be your side, side angle. So is it between? So this is what I mean by between. See, this is one of my sides, bam, right there. This is another one of my sides, bam. Okay, so my question is this angle that we're given in between the 2 sides? Yes, in fact, this is the angle that's formed by the 2 congruent sides. So it's definitely in between. It's definitely side, angle, side. So for number 5, we will say yes because of the side, angle, side postulate. Now, compare that with problem number 6. Again, we have 2 sides and an angle, just like we did on number 5. We have 2 sides and an angle. But this time, if you look at the 2 sides, you know, I have UV, that's a side, and I have VT, that's a side. Okay? The angle that is formed by those 2, the angle in the middle would be right here where the smiley face is. Okay? That would be the included angle. But that's not the angle that we're given. We're given this angle out here on the edge. So this is not the included angle. So this would be your side-side angle situation. All right, 2 sides and the angle that's not between them. So that's a no. And if I'm even going to write this down, I'm going to put an X through it to show that this is not a valid postulate. Did I do that up here? I meant to. For number 3, let's put an X through that because there is no angle-angle postulate. So I'm going to put an X there showing that that's no good. Okay, last one, number 7. We're given, this has a shared side, so I can definitely go ahead and mark that. Also, you see the 90-degree angle here. If that's 90 degrees, it'll definitely be 90 degrees over here. Now, if I just treated this as a normal problem, it would be another side-side angle, because here I have my 2 sides and the angle that's not in the middle. The middle angle would be up there. So normally this would be a no, but this is a special case. Because this is a right triangle, there's an additional property that I can think about. And it's this one that's called HL. What do you think HL stands for? HL stands for hypotenuse leg. Hypotenuse and leg. So let's look at this triangle and see, are we given the hypotenuse congruent and are we given a leg? Well, look at SR and UR. These are the hypotenuses, so we do have a hypotenuse. And look at RT, that is a leg. So we have a hypotenuse and a leg, so we get to say yes, these are congruent because of the hypotenuse leg. All right, that's a special theorem that only works for right triangles. Now, don't think automatically when you see a right triangle that it'll always be hypotenuse leg. It will not always be hypotenuse leg just because it's a right triangle. Just for example, just to make a point, say if we were not given those sides congruent. Say if instead we were given these sides. Well, this would be a leg and a leg. There is no leg-leg theorem. You have to be given the hypotenuse, okay, and a leg. So that would still be a no, even though it's a right triangle, unless you're given the hypotenuse. So just watch out for that. Okay, so that was a quick review on how to prove that triangles are congruent using these postulates: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Be aware that angle, 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 and side, side, angle do not work.